Okay guys, here is the second video in 3.1. Okay, 3-1, scatter plots and correlation, one of my favorites. One of my favorites. Okay, so here I'm gonna put a picture of a graph up. Okay, I am not going to draw it for you because it would take me too long. But it would be a good idea for you to make a quick sketch of this in your notes. I think it would. Okay, so I'm gonna put it here. So if you look at it, I've got time spent studying here, and I've got test grade here. So we're going to look at those two, and it's one that we would think should have a positive association, which means the more that people study, the better test grade they get. Okay? And if you can look here, I put some dots in different places. Okay? And the dots for these, I wouldn't do anything special. This is how I made it. And then I just made some big ones. So here I put 15 and 60. Okay, I labeled that point. And this point over here I labeled 40 and 80. So that's one that you could label. And then I put one up here that looks like it's 5 and 100. Okay, so we look at this. You look at this and we try to determine what can happen. Okay, what's happening between these two variables? Is there a relationship? Are these variables related? And as a teacher, I would like to think they are. I don't want to think that it doesn't matter if you're studying or not to how you do on my tests. I'd be horrified. Now there'd be some classes you probably go in and probably have, free time and you go and you get an A or a 99, but stats isn't one of them. So you guys have learned that by now. Make sure you have the time spent studying and the test grade so you can get the flavor of what it is we're talking about here, okay? So let's see if we can explain some of these, okay? This is your response variable. The response variable is your test grade. The explanatory variable is the time spent studying, because we'd like to think that your test grade can be explained by how much you study. However, there's always these people in the crowd, and I certainly wasn't one of those, who could study for 5 or 10 minutes and get 100 in the test. Now you guys might look at that person and say, well, maybe they cheated. Yeah, maybe you're right. Okay, if they didn't really study and they're getting 100 in a stats test, I haven't had it yet. I've been teaching this class since 2015, so 5-6 years, and I've never seen that. So I'd certainly want to find some evidence, okay, for that. But you look at these two. This person spent 40 minutes studying and got an 80. This person spent 15 minutes studying and got a 60. If I were to describe this, I would say it's probably somewhat linear. I would say the direction as the time spent studying goes up, the test grade tends to go up, which means it's a positive association. Not perfectly. An outlier, I'd say a possible outlier here at 5 minutes and a test score of 100. I would think that's an outlier. And in terms of strength, I would say it's probably moderate. Those points are kind of close together. Okay, so again, here we talked about direction, we talked about positive correlation, negative correlation. You already have that in your notes. I don't think you need to write that twice. Okay, in terms of form, we talked about linear, we talked about curved, we talked about no pattern, and then something that's strong association, maybe with an outlier, and these probably weak. Those points are kind of jumbled around. Someone might say, well, I think it's kind of moderate. Well, I don't know. So here's the little thing for outliers. Ready? This is something I learned from the person, Joe Nystrom, who taught me a lot about this course. He said, if it looks like an outlier and smells like an outlier, then it's probably an outlier. Okay, but the pinky trick will work. Okay, if I put my pinky, on that point right there, does that fall outside of the pattern of points? Yes. If I had a point way over here, that's probably not an outlier because it's still along the same pattern of points. Okay. Now, things with your calculator. Sometimes you could get what's called a mismatch error. Okay, it's just something that I've thought about, but a little mismatch error, and that's if you have more X's and Y's. We're going to be learning how to use this graphing calculator, and it's not always going to be pretty, okay? Not always going to be pretty. So That's one error. The best way that I have to fight through the errors is when you get an error message to go to Google and type it in. They have these little books that come with the calculators that are pretty much useless. Google is much, much, much better to use for that. So I would strongly, strongly suggest that when you guys have a question, go right to Google, type it in, and then that'll give you good tips in terms of how to troubleshoot with your graphing calculator. So, association does not imply causation. Just because two variables are associated does not mean that one causes the other, okay? Although there's a strong association, what variables are lurking in the background? Because both number of manatees killed and boat registrations increase, does that mean that for every time a person buys a boat registration, one of the manatees just rolls over and dies? That doesn't make sense, does it? No. There could have been other changes. There could have been sharks. Maybe there's not any patrols out there. Maybe people weren't patrolling the boats fast enough, because manatees, they like to go near the surface a lot, and a lot of times they get injured from people in boats. So just because the number of manatees went up and the boat registrations went up, you can't say it's just because there's more boats in the water. Okay, sharks could have been introduced to the area. There could be an increase in speed in boats. These are variables that are called lurking in the background, okay? They're not part of what's in for the study, but they could be there lurking in the background. So you can't necessarily just say, because one goes up, the other goes up, that they caused it. You have to be careful how you use that word caused, okay? So, we're gonna get into a little bit of this stuff, but I do need you guys to take out a separate piece of paper, or two, okay? We probably take 2 or 3 pieces of paper. This stuff's gonna be really important. I think it's better than this. This is very factual. You know, and we're gonna look at it. We're gonna look at it, and we're gonna talk about it, but I do think that if we're talking about correlation, that these notes are better. So when we talk about how things are, the strength of something, okay, the strength of a relationship, a lot of times you talk about the correlation, okay? And correlation, what it does is it measures the strength between two quantitative variables. I should spell that. Quantitative variables. Okay, so that's what correlation does. Okay, and we already talked about the old direction, form, strength, and outliers. Okay, we've talked about all that stuff, but correlation, we're starting to get how can we measure the strength of something? How do we measure the strength? Do you just look at it, or is there a way to measure it? And there is, and it's called correlation. Okay, so R, the letter R, small r, okay, small r, is called the correlation coefficient. Correlation coefficient. Okay? And it measures the strength of a relationship, measures the strength of a linear relationship. The values, the R values, are between -1 and 1. All of your R values are -1 and 1. Incredibly rare to find an R equal to 1 or an R equal to -1. Incredibly rare. You're not going to see that. Most likely it's going to be like 0.72, 0.38, -0.25. These are values of R. Okay, and it measures the strength of a linear relationship. So if I were looking at some, so you can say, well, what would one look like? If you had points that look like this, you might say the R is equal to a -1. We're going to do an activity that will go through this, okay, and on an applet. But for now, this is what we're going to talk about. And then, so if I said R equals -0.7, pretty good relationship, pretty strong relationship, okay? I would say that's strong, but not a perfect line. Might look something like that. And I'm estimating here, guys. I'm not sitting here looking at a book doing this. So now if it has no relationship, then it would probably look something like this, where the points are all scattered. And there you might say that your r is equal to 0. Now, for r to be equal to a positive 0.7, your points would probably look like this. Okay? And then r is equal to 1. Looks like that. So, if you look, the r and your slope would have the same sign. Okay, it would have the same sign. So this one, if you drew a line there, your slope would be negative, your r is negative. Again, slope negative, r negative. Slope positive, r positive. Slope positive, r positive. Okay, now, how do they calculate it? I'm going to say they. How do they calculate it? And the reason I say they is you're never going to have to do this. Okay, you're never going to have to do this. But I do want you to understand how they come up with it a little bit. Okay, just a little bit. So let's picture a scatter plot. Now, I'm hoping that when you guys see this, you would agree with me in terms of saying that it's a positive association and that the r would be positive. The slope would be positive and the r would be positive, okay? So these are all my x's and these are all my y's. Now what I want you to picture is, picture if I took all of these x values, okay, and I added them up and divide by the number they had. I found an average x value. And I did the same thing here and I found the average y value. Well, if we did that, okay, this is where I think your average x would be. And I call that delta x. That's where it's the middle of all the x's. If my x's go from here to here and the points are about the same, about number, if I average them, my center would be here. The same thing with my y's. They go from here to here and I averaged up all the y values, I think they would be right around here. So there is delta x, delta y. And if I made a vertical line and a horizontal line, I create 4 little quadrants. Okay? So I want you to think of all of these points. Okay? All of these points. If I were thinking of these being, this side being positive and this side being negative, think of this as your coordinate plane. Okay? And up here, your x's are positive and your y's are positive. Here your x's are negative and your y's are positive. Here your x is negative and your y is negative. And over here your x is positive and your y is negative. Okay? So, if this is where the average x's are, these points for my x's are above average. They're above average. They're to the right of where the average x is. This is where my average x was. Okay, if this was 0 and this was 10 and I averaged it and it came out in the middle somewhere around 5, all of my x's, then these points here are above average for my x, but they're also above average for my y. So for my x's and my y's, it's a plus and it's a plus. Okay? Down here, these values, well, they're smaller than my average for x, so they'd be like a negative x. And they're smaller than my average for my y's, so they're a negative y. So those are negative, negative. This is positive, positive. If you have those, if I had a positive over a positive, I would get a positive. If I had a negative over a negative, I would get a positive. So that's why my correlation's positive, because all the values are either both negative or both positive. Okay? Let's say I had a negative association graph. Okay? And I found the averages, and I said, well, my average x looks like it's right around there, because they run from here to here. My average y, we'll say that's right around there. So there's my delta x, there's my delta y. So what kind of values do we have over here? Well, they're below average for my x, because they're to the left. They're smaller than my average x. So my x is negative, but my y is positive. So I have one positive and one negative. Over here, my x is positive, and my y is negative, So again, one positive, one negative, one negative, one positive. So if you look here, one's positive, one's negative, you're going to have a negative correlation. This is a positive correlation, a negative slope, a positive slope. Okay? So that's how they come up with it. I'm never going to ask you, they're never going to ask you, but I wanted you to have some kind of an idea of what it means. Okay? So, we are going to do a little example here. We're going to do a little example, okay? So, let's see. I'm going to put this out, okay? Because I don't want to copy this. I don't want to waste time. I want to make your time as valuable. I know your time is valuable, okay? So, here's an example. Let's see if the number of texts, and we're going to actually, I'm going to show you how we are going to calculate R. Here's they. Here's the book, okay? Here's us, the common folk, okay? Let's see if the number of texts you sent is associated with your grade in the quiz. So if someone's texting a lot in class, and they're constant texters, they're probably not getting the highest average in the class because they're not paying attention. Okay, so we're going to see if there's a relationship there. So in L1, we're going to put our number of texts. That's going to be our X. That's going to be our explanatory variable. And in our Y, we're going to put our quiz grade. Okay, that's our Y. And you see all of our quiz grades. Those go into L2. So what I want you guys to do is to pause the video. Okay, pause the video and put those in, or maybe be easier. Okay, maybe be easier if I do stat and I do edit. Maybe I read these to you. If that's easier, you don't have to keep looking down at your paper. So if you want me to read them to you, I'm going to do that now. If you want to do it yourself, just push pause and copy them down. Okay, but the first one's 12. I'm doing my X's first. These are in L1, then 14, and then 10, and then 13, and then 26. Jesus, someone sent 26 texts in a class. I'm surprised they could get any questions right. 11, 6, 38. Ouch. All right, so I put those in. And now we're going to do the same thing for the L2s. I'm going to hit clear, and I'm going to hit enter and clear out that data. And now I'm going to put in 97 and 75 and 86 and 72 and 64 and 79 and 88 and 45 and 58. Okay, and now I'm going to hit graph. It should be set up for a scatter plot. As you can see, I've only got one point there. That means I have to do my zoom, so I'm going to hit zoom 9. And I have my points. And so let's look and see if we can interpret this graph. This is my number of texts. Okay, this is my number of texts. This is the quiz grade. Okay, number of texts and then quiz grade. So what happens as the number of texts goes up? As the number of texts go up, looks like for the most part the quiz grades go down. Okay, so the people who are sending the most texts are getting lower quiz grades. All right. So let's do some interpretation here. Now, let's say I wanted to find out what R was. Okay, I wanted to find out what R was. So this is what we're going to do. You're going to hit your stat button and put this in your notes so you have it when you need it. Okay, hit your stat button, arrow to calc. Okay, and then when you're at calc, we're going to do 2 variable. We could do 2 variable statistics if we want to find the mean, the median, mode, but I don't want to do that. I have to do what's called linear regression, and I'm going to go down to number 4. Okay, there's 2 linear regressions. There's a number 4, and then there's a number 8. Actually, 8's the one that we really use in statistics. They're both the same, but this lists the intercept first. We're going to learn that in section 3.2, but you can do 4 or 8. Hit enter. L1 and L2, I already have them there, which is good. Hit enter a few times. Oh, and see, this is good. I'm glad this happened. So I look, and I only have an A and a B, and it gives me my slope and my intercept. We'll come back and use this in 3.2. I wanted it to say R. So it didn't, so I have to turn on my diagnostics. So if anybody's had an R, you don't have to do this. Okay? But if yours doesn't come up with an R, like mine didn't, hit second catalog, and then I want to get to R. I could scroll